Welcome. On this video, we're going to be discussing the division of polynomials, and we're going to be using the technique of long division. So let's get started. Let's start by looking at the small introduction question, which states, graph the following equation and identify the zeros. So here we have this polynomial or this function, 6x cubed minus 19x squared plus 16x minus 4, and we want to identify the zeros. One way that we can do is we can just graph it. And if we were to graph this function, we would obtain the following. So we go to our decimals activity. Notice this is the same function that we had on the polynomial. And we have 3 zeros. We got 1 at 2. And we also have 2 more here, at 0.66 and at 0.5. So we have 3 zeros, and I already have them here. So we have 1 0 at 2. We have another 0 at 0.66 and at 0.5. And this agrees with the fundamental theorem of algebra, because notice that the highest exponent is 3. So we should expect 3 kind of solutions, and we have them, 1, 2, and 3. So how is this small introduction, or how is identifying the zeros going to help us understand the division of a polynomial? Well, we're actually going to just concentrate on the solution x equals 2. So we're just going to concentrate on the solution that we got here, x equals 2. Well, if x equals 2 is a solution, then x minus 2 is a factor of the function that we started with, f of x. Saying that f of x can be written as x minus 2 times some other expression. And how are we going to find out what expression that is? We're going to be using polynomial division. More than anything, long division. We're going to use the technique of long division. So this is what we're trying to state here. Well, notice that x equals 2 is a solution to the polynomial. Then that implies that x minus 2 is a factor, which means that there should exist a second degree polynomial, let's call it q of x, where f of x is equal to the factor that we found out times that expression. And the way that we find out that expression q of x is by using long division. Well, notice that long division is not going to be the only technique that we're going to be discussing, but today we're just going to concentrate on long division. So now let's introduce the technique of long division now. So let's use long division to factor the polynomial, which it was given on the introduction question. So the way that we're going to set up our long division is the following. We're going to always get the function that we've been given, which in this case is 6x cubed minus 19x squared plus 16x minus 4. So let's just write it out. So we got 6x cubed minus 9x squared plus 16x minus 4. And what we're going to do, we're going to put it inside of a box. And what we're going to put down right here on the left-hand side is what we want to divide by, which in this case, we want to divide by x minus 2. Because essentially what we're doing here is the following. So using this technique, let me call this q of x then, since this is how we have discussed it on the small introduction here in the bottom. This is our objective. Our objective is to define what q of x is. Well, notice that since this is multiplying, I can divide it by x minus 2. And that way, I can say that the expression that we're looking for, which is q of x, is equivalent to f of x over x minus 2, or 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. And the way that we write down this division is going to be the numerator. It's always going to be inside the box. And the denominator, we're just going to write it on the left-hand side of the box. So this is just the setup. So this is the numerator, and it's been divided by x minus 2. Now, how are we going to define this q of x? Well, this q of x is going to be defined by the following procedure. The first thing that we always want to do is make sure that my expression is in descending order. So cube, second, first, no degree. So we're good. So now that we have that out of the way, we can start the procedure. So the procedure is going to be the following. What we want to do now is I'm going to take a look at the first expression on the outside and the first expression on the inside. And I'm going to be asking myself this question: x, what do I need to multiply so it matches 6x cubed? So x, what do we have to multiply so it matches 6x cubed? Well, notice that x, if we multiply it by 6x squared, it's going to be equivalent to 6x cubed. So we're going to multiply by this expression. And now that we have defined that expression, which in this case is 6x cubed square, we're going to multiply. So x times 6x squared, so that's definitely 6x cubed, which is what we wanted. Now, it's not just that we're just going to multiply x, but we need to multiply the whole expression. So we already multiplied x, and we got this. Now we need to multiply -2. So we're going to say -2 times 6x squared. Well, that's equivalent to -12x squared. Now, this is where it gets tricky, because on the procedure, every time that you multiply, after the multiplication, you always want to change the sign. In this case, 6x cubed is positive, so before we combine like terms, we need to change the sign, which is going to be a negative. We got -12x squared, so before we combine, we got to change the sign. It becomes a positive. And now that we have properly changed the sign, now we can combine. So let's just write it out. So after you multiply, always, after you multiply, you change the sign before we combine. Always. This is just part of the procedure. And now that we have properly changed the sign, let's combine them. Well, notice that if we combine them, this term is going to cancel out. And that's essentially what we wanted. We want to start reducing our expression. So we're going to try to eliminate terms, one term at a time. So that cancels out. And now -19x squared plus 12x squared, that's equivalent to just -7x squared. And now these two expressions that we do still have left here, we're just going to bring them down. So if we bring this down, we're going to have 16x, and if we bring this down, it's going to become -4. And now that we have this, we repeat the process one more time. So the first expression on the outside, it is still x, and now the first expression on the inside is -7x squared. And now we ask ourselves this question: x, what do we need to multiply so it matches -7x squared, which in this case is going to be -7x. Now we multiply. So let me just erase that. So now we multiply. So now we got x times -7x. That's definitely -7x squared. And again, we don't just multiply x. We also need to multiply this -2. So -2 times -7x, that's 14. Positive 14x. And again, before we multiply, or after we multiply, we need to change the sign before we combine. So let's change the sign. So this was a negative, let me change it to a positive. And this was a positive, let me change it to a negative. So now that we have done that, now we can combine. So this is going to cancel out, which is essentially what we wanted. And now let's combine the rest. 16x minus 14x, well, that's equivalent to just 2 of x. And now we're going to bring this down, -4. And we're done with the second step. Notice that we're doing the same step, but now we're going to do it as many times as possible. Now we repeat the process. After we combine, we repeat the process. So we got an x. Now, what do we need to multiply so it matches the first expression on the inside, which now is 2x? Well, in this case, it is 2. And now that we have figured out the next term, what we're going to do, now we multiply. So we got x. And if we multiply times 2, we're definitely going to get our 2x, which is what we wanted. Now negative 2 times positive 2, well, that's equivalent to negative 4. And again, before or after you multiply, before you combine, we change the sign. So let's change the sign. This was a positive, let me change it to a negative. This was a negative, let's change it to a positive. And now notice that they both cancel out and we got 0. Now, this expression that you do end up at the end, this is what we call the remainder. And very important, if your remainder if the remainder is equivalent to 0, then what you divide, which in this case we divided by the expression x minus 2, is a factor. And this is something that we were expecting because we already knew that x minus 2 was a factor. So therefore our remainder is equivalent to 0. So now if we come back to what we initially stated, now we can say that f of x is equivalent to x minus 2 times the expression that we end up here on the top, 6x squared minus 7x plus 2. So now the process that we did in here, this is what we refer to as the long division process. But we use the division process to answer two questions. Well, the first one is x minus 2 a factor? We already know that it's a factor, but we can confirm that it's a factor because after doing the process, we got a remainder that is called, we got a 0 that is called the remainder. And if the remainder is 0, then it is a factor. Now, since x minus 2 is a factor, we can also conclude that x equals 2 is a solution. And this is because x minus 2 is a factor. So notice the kind of information that we can gather from just doing the long division. So let's just do one more problem, still dealing with long division, where the question state is x equals negative 1 a solution to the function. Well, one way that we can do is just, get this value, plug it in, and if it's equivalent to 0, then we know that it's a solution. But we want to do it a different way. One way that we can still verify that, if x equals negative 1 is a solution, then x plus 1 should be a factor. And if x plus 1 is a factor, we need to have a remainder equivalent to 0 after the division. So let's see if we actually get that. So let's find out what happens if we have the following. So if we get x squared plus 3x plus 5, and we're going to divide by the expression x plus 1, and if we have a remainder of 0, well then x plus 1 is a factor and x equals negative 1 is a solution. So this is the strategy that we'll be using. So let's actually do it. Let's get what's on the numerator, which is x squared plus 3x plus 5. And now let's divide it by the expression x plus 1. Before we proceed, we have to make sure that inside our box, everything is in order. The first thing, is it in descending order, second exponent, first exponent, 0 exponent. So it's good. Is there anything that is missing? No. In terms of missing, I mean, let's assume that we have the expression x to the cube plus x plus 3. And this is a completely different problem, nothing to do with what we're doing right now. Let's assume that we have this and we want to divide it by x plus 1. The way that we would have written that is we're going to write down x squared plus 0 x squared plus x plus 3 with the box of x plus 1. So this is what I mean by, is there anything that is missing? Note here that if we want to write it in descending order, x squared, it's missing. So the way that we just write it out in our box is by putting a coefficient of 0. Because 0 times x squared, it is 0. So we're essentially saying that we're adding 0, which it doesn't affect what we originally stated. So now coming back to the actual problem, notice that we don't have that scenario, so we don't have to worry about that. So let's actually perform long division. Take a look at the expression on the outside and take a look at the expression on the inside. And we ask ourselves this question, x, what do we have to multiply so it becomes x squared? That's pretty straightforward. It's just an x. So now that we know what that is, let's actually multiply. So x times x is x squared, and 1 times x, it is just x. Let me get rid of this mark. And again, before we combine, we have to change the sign. So let's change the sign. It was a positive x squared, it becomes a negative. It was a positive, so now it becomes a negative. And now let's combine, now that we have changed the sign. Well, this is going to cancel out. 3x minus x, well, that's just 2x. This 5, we're just going to bring it down to 5. And now we repeat the process one more time. So we have an x. Now what do we need to multiply? So it becomes 2x, which in this case, it is just 2. And now we multiply. Let me erase the mark. So we got x. We need to multiply times 2, so that becomes 2x. And 1 times 2, it is positive 2. And again, before we combine, we got to change the sign. So let's change this into a negative. It was a positive. Let's change it into a negative. And now let's combine. And if we combine, the first term goes away, and we got 5 minus 2, which is equivalent to 3. So notice that now we have a remainder of a value of 3. So therefore, let me just write it out then. So since our remainder is not equivalent to 0, then the expression that we divided by, which in this case was x plus 1, is not a factor. Therefore, x equals negative 1 is not a solution. And the objective of this lesson was not just to teach you how to do long division, because long division is just a process. You multiply, you change the sign, you combine. You multiply, you change the sign, you combine. But what I wanted to concentrate is what are the uses that we can do with long division. We can do two things. We can arrive to conclusions if expressions are factors, and also if certain values are solutions. And with this, it concludes our lesson for the division of polynomials using long division.